So yeah, today I got to talk about arrays in the C programming language. An array is a fixed size collection of elements of the same data type. Think of it this way. An array is similar to a variable, but it can hold more than one value. It's a little more complex than that, but that's a good way of thinking of it. Here's a demonstration. I'll create an int of number. Set it equal to some number. This is a variable. Well, I could convert this to be an array after the name of the variable, add a set of straight brackets, enclose any values with the set of curly braces. Then you can add more than one value, but they have to be comma separated. I'll add 20, 30, 40, 50. The name of your array should be descriptive of what it contains. Instead of number, singular, I'll say numbers, plural. That makes more sense, because we have a couple numbers in here, rather than just one. Now, if I were to print my numbers directly using printf, for example, I'll display an integer, and I will display my array of numbers. Here's my result. I get some really long, funky number. Normally, if you pass an array to a function, including printf, it decays into something called a pointer, but that's a future lesson. We'll run into unexpected behavior. Rather than printing the name of the array, we're going to print the elements within this array. Each value in an array is an element. To display my array at the first index, take the name of your array, add a set of straight brackets, then list an index number. For the first element in an array, you actually use 0, because computers like to start with 0. If I were to print this, this would display 10. Numbers at index 0, that's 10. Index 1 is 20. 2 is 30, 3 is 40, 4 is 50. If I attempt to access an element that doesn't exist, well, we're out of bounds technically. You'll get some sort of garbage value, and in my example I got 624. In C programming, you can go out of bounds when working with arrays. In most other programming languages, you'll encounter an error, usually some sort of index out of bounds exception. But we don't have that luxury in C. Be sure that when accessing elements, you don't go out of bounds. In my array, I have 5 indices, 0 through 4. Let's create a few more arrays. It'd be good practice for us. Let's create an array of characters, named grades. These are letter grades. Let's start with a single variable. Just a character of A. I'll convert this variable to be an array. After the name, add a set of straight brackets, enclose all values within a set of curly braces, comma separate each value. A, B, C, D, and F. Let's change grade to be grades, because that's more descriptive. Rather than displaying an integer, let's display a character, %C for the format specifier. Let's display grades at index 0. That's going to be an A. Index 1 is B. 2 is C, 3 is D, 4 is F. An array of characters is very similar to strings in C. When we've created strings, we would declare an array of characters, such as name, equals, then within double quotes, we list a bunch of characters. These are both arrays of characters. If I were to display name at index of 0, it should give me a capital B, which it does. Index 1 is R, 2 is O. After creating an array, you can change the values, but you have to access an index number, which is what we did here. Let's display numbers at index 0. We're displaying an integer. We'll access our array of numbers at index 0, then change it to be 100. Set it equal to 100. That should give me 100. Let's do this with the others. I'll do a lot of copying and pasting. Index 1 will be 90. 2 will be 80. 3 is 70. 4 will be 60. Then let's display all these. I'll add some new lines. Numbers at index 0, then 1, 2, 3, 4. And here are my numbers. I have 100, 90, 80, 70, 60. If you do need to display all the elements of an array, you could use a loop. Here's a demonstration. Let's say I would like to display my grades. I have 5 grades within here. I need a for loop to cycle 5 times. For int I, set that equal to 0. Continue as long as I is less than 5. Increment I by 1 after each cycle. During each cycle, I'm going to print the following. We're displaying a character this time. I'll add a new line, then display my array of grades. Rather than putting a number here such as 0, 1, or 2, we're going to use I. After each cycle of this loop is complete, we're incrementing I by 1. It'll start at 0 and stop at 4, because that's what we set the condition to be. Here's the output. I get the letters A, B, C, D, F. Rather than using a new line, let's use a space to separate each element. A, B, C, D, F. Let's display numbers. Numbers at index of I during each cycle. Oh, but we have to display an integer, not a character. There we go. 10, 20, 30, 40, 50. Let's display our name. And then we are displaying a character. Well, my name gets cut off, because we're only looping 5 times. For this for loop, I have to manually change the condition. In my name, I have, let's see how many characters. 1, 2, 3, 4, 5, 6, 7, 8. I would have to manually change this for loop, and that's a lot of work. But we display all the letters of my name. Let's go back to numbers. Let's say that I set the condition to be I is less than 5. And we're displaying an integer. What if I add a new number, such as 60? Well, we're only cycling 5 times. If I need to display the full length of the array, I would manually have to change this condition to be 6, because there's 6 elements. We have 10 through 60. Wouldn't it be nice if we can calculate automatically what the size is going to be, the size of the array? Well, there's one way in which we can do that. Here's a trick. Just for the time being, I'm going to comment out this for loop. We can use the size of function to get the size of something, whatever we pass in. I'm going to print the following 2 things. We're going to display an integer. I will display, call the size of function, pass in my array of numbers. The size of function will give you the size of something in bytes. My array of numbers, it takes 24 bytes. 24 bytes of memory. Now let's get the size of one of the elements. Printf, %d, because we're displaying an integer, get the size of one of the elements. Numbers at index 0. The reason that I'm choosing 0 rather than 1 or some other number is because what if our array only has 1 element? Numbers at index 1 would be out of bounds. So people go with 0. Then let's add some new lines. The size of my array is 24 bytes. The size of one of the elements is 4 bytes. If we divided the size of the array by one of the elements, that's going to give us 6. 6 elements. If I were to add another element, the size of my array should change, but the size of one of the elements is going to stay the same. Now my array is 28 bytes. The size of one of the elements is still 4 bytes. Let's change that back. Why don't we divide the size of the array by the size of one of the elements? That's going to calculate the number of elements in my array. We'll declare a variable. Let's name it size. Equals, call the size of function, return the size of my array numbers, divided by the size of one of the elements, numbers at element 0. In my example, size should be 6. Then with our for loop, let's bring that back in. Size will be 6. will continue as long as I is less than the size of our array, the number of elements, that is. And we should get the numbers 10 through 60. Let's add a few more, just to be sure that it's working. Let's add 70. Yep, we have 70. Then 80. And we have 80. If you would like to condense some of this code, you could copy this section where we divide the size of the array by the size of one of the elements. We'll cut that, delete this line. Then we'll continue while I is less than whatever number is returned from this equation. The code is more condensed, but it's less readable, especially for a beginner. Use whatever technique you would prefer. Alright everybody, those are arrays. They're a fixed size collection of elements of the same data type. They're similar to variables, but they can hold more than one value. It's nice if you need a collection of something. And well everybody, those are arrays in C.